Expand the contents of the volcano types KMZ and double-click on each volcano in the list to zoom to it. The first volcano is SP Crater in northern Arizona, and this displays all the characteristics of a cinder cone. A smooth conical shape with steep sides indicates that the cone formed from a single vent which ejected hot lava charged with gas. The next volcano is Mauna Loa on the Big Island of Hawaii. The massive size, gentle slopes, and numerous flows are characteristics of shield volcanoes. Basaltic in composition, the most recent flows are darkest in color and have shapes indicating that the lava was very fluid when it erupted. Composite volcanoes, like Mount Rainier near Seattle, typically have steep slopes, light-colored rocks, and sharp conical shapes, and form from both explosive pyroclastic and sticky lava flow eruptions. The next volcanic form, known as lava domes, are usually smaller in size, like the Mono craters near Mono Lake, California. The next volcanic form, this caldera in the Jemez Mountains of New Mexico, formed when a large-scale eruption emptied the magma chamber at depth, which allowed the overlying rocks to collapse inward. Calderas are the depressions that form from these collapses. Each volcano doesn't have to fit nicely within the categories outlined here. Often there are smaller-scale volcanic forms within or on top of larger volcanoes. After the catastrophic eruption of Mount St. Helens in 1980, a volcanic dome grew within the crater. In the next volcano, we can see cinder cones that have formed from smaller scale eruptions on the slope of a shield volcano. And finally, in Crater Lake, there is a cinder cone that formed within the collapsed caldera, both of which are part of the larger composite volcano. The next 4 unnamed volcanoes in this list are for you to identify in the questions. Click the open box next to the subdirectory Earth's Tectonic Plates to display the plate boundaries. In the Layers window, expand Gallery and select Volcanoes. When you zoom in, the place marks represent the locations of volcanoes that are considered potentially active by the Smithsonian Global Volcanism Program. The distribution of volcanoes around the planet is very similar to the distribution of earthquakes. Along subduction zones like the Aleutian Arc in Alaska, volcanoes are common. Along transform boundaries like the San Andreas Fault in Southern California, volcanoes are incredibly rare. Finally, along continental divergent boundaries, such as the East African Rift Zone in Ethiopia, volcanoes are typically abundant. This volcano dataset does not include most of the volcanoes that are under the surface of the ocean, but these divergent boundaries along mid-oceanic ridges are composed of almost continuous volcanic vents.